Okay, good morning everyone. Am I audible?
Yes, sir.
Yes, sir.
So we have started. So a very good morning all of you. So we have discussed in our last classes, this is our different types of transducer, okay? And we have completed what is transducer, what is the different classification of this transducer. So you know that there are two types of transducer we have to broadly discuss, that is active transducer and passive transducer. And also we have to discuss the definition of active and passive transducer, what is the basic examples and what is the principal operation of the one by one passive and active transducer also. And side by side we have to also discuss the application. So in this module, you all of you seen that is there are broadly discussed in the different types of physical parameter in your syllabus, that is temperature measurement, pressure measurement, flow measurement, speed measurement, and position sensor. These are basically transducer of physical parameters we have to discuss in broadly. So first of all, we have to discuss temperature measurement, because we have started last classes the temperature measurement also. So you know that this temperature measurement, so we have to uses different types of devices for measurement of the temperature measurement. Okay, so first of all of you seen the thermometer. Using this clinical thermometer or doctor thermometer, you have to easily measure the temperature of the human body. Okay, so these are the basically simple examples of the temperature measurement. Okay, another in our industrial purpose, we have to use this temperature measurement. There are the lots of device we have to connect it. Okay, so thermistor, thermostat, that is another one, that is also thermocouple. Okay, pyrometer. These are the basically different industrial applications of the temperature measurement. So we have to discuss this broadly. Today's topic is temperature measurement, that is today we will discuss the thermistor. Okay, so first of all you have to know what is thermistor. Okay, so you know that this thermistor basically it is also called one type of thermal resistor. Okay, this is basically one type of thermal resistors. Okay, so I am written the definitions. This definition is very much important. So thermistor are also called the thermal resistor, thermal resistors, and the name is derived from thermally sensitive resistor as the resistance of a thermistor varies as a function of temperature. Okay, so this is the basically definitions of the thermistor. So I am repeats again. Thermistor, it is basically called the another name is thermal resistors. thermal means that is a heat resistance. Okay, so these thermal resistors and the name of the derived from the thermally sensitive. Okay, that means thermally sensitive. That means the hot body temperature it is that is increases or sometimes it also decreases. So using this temperature senses, that is the thermally sensitive resistor, or the resistor of a thermistor varies a function of the temperature. That means the temperature it is changes, either it is decreases or increases. So using this temperature decreases or increases, the resistance property, you know that we have to use it as a resistor. This resistance property it is also changes. So this changes, it is basically using the one device. This is called the thermistor. Okay, is it okay?
Yes, sir.
And it is a passive component. So please note down it, because sometime MCQ question it is also available. So क्वेश्चन ऐसे भी आप लोगों को दिया जाएगा, थर्मिस्टर इज ए ऑप्शन दिया जाएगा, एक्टिव, पैसिव, बोथ और नन ऑफ दिस. सो प्लीज अंडरस्टैंड दिस इज बेसिकली थर्मिस्टर इज ए पैसिव component or passive transducer. Okay, and this is basically we have to uses, basically it is uses accurate. These are the basically some of advantages. This is accurate result you have to give you, and it is also cheap. Okay, and it is also robust. That means you have to use it whatever in place, that is a hot area or coldest area or humidity area. So these are the basically characteristics of the thermistor. That's why you have to easily for measurement the temperatures. Okay, so robust, sorry, it is way to measure temperature. So when you have to use it in industrial purpose, some of the temperature senses applications, you have to use these temperatures, that is a thermal resistor or thermistor. Okay, so in the year of 1935, okay, in the year of 1935, first it is discovered. Okay, so first it is discovered by a different types of material we have to consider here also. So what type of material we have to use is, I am going the next page. 1 minute. So basically we have to use the materials. Materials are used for thermistors, that is manganese. Manganese we have to use as, nickel we have to use as, cobalt, copper, okay, iron, zinc, aluminium, titanium. Okay, another one, magnesium also used, and uranium. So these are the different types of material we have to uses for making for the thermistor. Manganese, nickel, cobalt, copper, iron, zinc, aluminium, titanium, magnesium, and uranium. So using the different types of material, and whatever we have to use is in our different application oriented. Okay, so जैसे मान लीजिए यूरेनियम type of thermistor we have to use it in our nuclear power plant. You know that nuclear power plant, there are the temperature it is too much high. So in the high temperature measurement, we have to use this uranium type of material. Okay. So these are the basically different material using the different application oriented. We have to use this the thermistor. Okay. Is it okay, all of you? So basic principles. So principles of operation. Principle of operation, that is thermistor. Thermistor. Basically, it is essentially a semiconductor device. It is a semiconductor devices. You know that. It behaves as a resistor with high negative temperature coefficient. Okay, the range is that is usually minus 0.04. This is 0.04 per degree Celsius at room temperature of 25 degrees Celsius. Okay, so this is basically one of the semiconductor device. You know that. So it behave as a resistor with a high negative temperature coefficient. So when it is working in the room temperature, it is changes. That is the value of minus of 0.04 per degree Celsius. Okay, and it is a least 10 times of sensitive of the platinum resistance thermometer. Okay, so one of the diagram how it is also changes. So basically diagram we have to plotting this one, another one. This is temperature scales. This is resistance in ohm, and this is the temperature. This is degree Celsius. So basically it is changes the graphical structures. That's like of this pattern. Okay, so this curve, it is basically dependent on that what type of material you have to use. Sometimes you have to use a platinum material, sometimes you have to use iron, zinc, magnesium. That are the basically using the different material property. You know that there are the different properties of material. There are the temperature ranges. It is difficult. There is a different types. So using these different types of material, the radius curvature of the different type of different material. Okay, so these are the basically different operations. So the resistance, that is R of a thermistor at a room temperature or at a temperature T. We have to express at temperature T can be given by the expression The equation is R is equal to alpha e to the power beta by t. This is the equation number 1. So please remember these things also. Here, the alpha and beta, it is basically constant, where alpha and beta, this is beta, are constants depending upon the material and and manufacturing techniques used. Techniques. Techniques. Okay. So this is the basically one expression of the thermistor, that is R is equal to alpha into e to the power beta by t, where you know that R is the basically resistance of the thermistor, T is the basically temperature, and alpha and beta, you know that this is basically constant. It is dependent what type of material you have to use and manufacturing techniques you have to use particular thermistors. Okay, up to this part it is okay. Please respond.
Yes, sir.
Is it okay or not? Am I audible? तो प्लीज आप लोग मतलब रिस्पांस दीजिए, क्योंकि मुझे भी नहीं पता चलेगा मतलब मैं राइट वे में मतलब चल रहा हूँ या रॉन्ग वे में चल रहा हूँ, क्योंकि रिस्पांस देना चाहिए. अभी देख रहे हैं 41 पार्टिसिपेंट है, बट रिस्पांस इज टू मच लो, सो दिस इज वेरी बैड. ओके, सो द approximate relationship between resistance and temperature, resistance and temperature applying to most thermistor it can be obtained by the equation for temperature, that is also T1 and T0. So the equation is changes. R1 is equal to R0 e to the power beta, that is also 1 by T1 minus 1 by T0. This is the equation number 2. Okay, so here we have to learn that is the relationship of the temperature between the resistance and temperature, that is R and T of the most of the thermistor. It is basically changes first state, that is T1 or T0. Okay, so these are the different temperature ranges we have to changes. That is initially we have to start it. After some time it is also another temperature it is also shown. So these are the basically temperature changes we have to calculate it here. Okay, using the this resistance, this equation form. So where this R1 and R0, it is resistance in ohm at absolute temperature. At absolute temperature T1 and T0. This is T1 and T0. T0. Next page में जा रहा हूँ. And beta is a thermistor constant. Okay. So here this beta it is a thermistor constant. That means it is also changes different times of also. So this beta it is basically expressed as the Kelvin scale also. Okay, and the value maximum value is 4000 Kelvin also. Okay, so here you can write this beta. It is expressed in Kelvin scale and is of the order of 4000. Okay, so these are the basically mathematical expressions how you have to calculate the thermistors. So next, that is temperature coefficient. How to calculate the temperature coefficient of the resistance in thermistor. So temperature coefficient of resistance, that is alpha. You know that this is basically changes dt of R1 divided, this is the R1 it is equals to minus of a beta by T2. This is the equation number 3. This is the basically expressions of the temperature coefficient calculation for a thermistor remover. So here alpha is not constant term because you know that it is changes, because the temperature it is also changes, so that means the alpha value it is also changes here. Okay, so it basically it actually drops with rise in temperature. Rise in temperature, because you know that when the temperature it is also increases, the resistance it is also drops also here. So the alpha's value it is also changes. So that's why it is not constant term. Okay. So now one examples, the clear idea you have to give him. If a beta value is 4000 and temperature T is room temperature, that is a 25 degrees Celsius, or it is Kelvin, you have to convert it to 98 Kelvin. So in that case, the temperature coefficient, so the temperature coefficient of resistance, that is, I'm written here, that is alpha is equal to the value of the beta, minus of beta by T2. So minus beta, that means the 4000, T2 is the here 25 degrees Celsius, but we have to convert it in the Kelvin scale, because you know that basically you have to calculate it Kelvin scale, we have to mostly one. So T2 here also present. Sorry, I am mistake here. That is not T2, this is T square. Okay. So this is T squared. Okay, so this is mistakes by mistakes. This is minus beta by T squared. That means these are the basically square, and we have to calculate it. The result is coming near about 0.04. Okay, that is 0.05452. That is considered for 0.04. This is ohm per degree Celsius. Okay, so this is the basically one examples of the temperature coefficient, how it is also changes. Okay, up to this part it is clear, all of you?
Yes, sir.
Yes, sir.
Response everyone. Okay. So this is the principle of operation of the thermistor, how it is also working. Now, there are different types of commercial thermistor we have to use. So I'm written here the types of thermistors. First of all, it is classified different categories. I am one by one discuss. First one is bead type. Bead type. ये कैसा होता है देखने में? देखो, ऐसे सर्कुलर एक तो प्लेट रहता है, यहाँ से दो लीड आता है. So this is a basically a glass coated. ये glass coated रहता है for protective device, and this is the basically different leads. Different lead wire. Okay. Another one. This is probe type. Probe type. इसको देखने में कैसा होता है? The same as previous one. ऐसे these are the basically different leads, and इसको एक ग्लास कोटिंग, शीशा का एक कोटिंग इसको ऐसे करके रखता है. So this is made for glass, and this is the lead wire. Okay. Number third, disc type. Number third type of disc type. कैसे दिखता है? ऐसे सर्कुलर एक डिस्क जैसा होता है. ओके, जैसे मान लीजिए आप लोग कॉम्पैक्ट डिस्क देखे हो, सीडी जो वगैरह यूज करते हो, वो ऐसे होता है. These are the basically lead. Okay, this is the lead wire. This lead wire connected to the different input and output terminals. Another term. Okay, everyone write your own name and roll number in the chat box also. And I think Rahul is present. Rahul, regular student Rahul. Not present.
So show me the.
Muskan is present.
Yes, sir.
You take a screenshot, okay? After ending the class, you have to send me. And everyone, please write your own name and roll number in the chat box also. Okay, so another number 4. This is the washer type. This is the washer type of thermistor. देखने में कैसा होता है? Washer. You see the different types of washer system. This is circle. This is basically you have a circle होता है, ठीक है? So these are the basically washer type of thermistor. and another type that is a rod type. Rod. So these are the different classification, different structures oriented of the thermistor. कैसे दिखता है ये? ऐसे ऐसे इसको कनेक्ट होगा ऐसे. These are the lead. So this is the lead wire. Okay, this is the different. यहाँ पे देखो, यहाँ पे लीड वेयर जैसा कुछ नहीं है. ये जो सेंटर पॉइंट है ना, ये मेटल का होता है. ये मेटल जो यूज होगा ये मेटल के साथ कनेक्ट होगा. सो यूजिंग दिस सेंटर पॉइंट इज मेटल, इट इज बेसिकली as a work for the lead wire. Okay, so these are the different types of thermistor: bead type thermistor, probe type thermistor, disc type thermistor, another one washer type thermistor, and last one is the rod type thermistor. So here the difference of sizes is available. The bead type thermistor, its ranges I am written here, that is 0.1 millimeter to 1.25 millimeter इसका साइज होता है. So what is the size of probe type? Probe type का जो साइज होता है that is a 2.5 millimeter. Disc size इसका जो साइज होता है that is 2.5 to 2.5 millimeter to 25 millimeter. Okay, so this is the different ranges. And another one that is the washer type. इसका साइज जो होता है near about 90 millimeter इसका साइज होता है. And rod type इसका जो यूज होता है 1.3 millimeter to 4.4 millimeter. So these are the different diameter of the different types of thermistors. Is it okay? Now the question is another one important short question MCQ. What is the ranges? What is the ranges of this thermistor? ये question आप लोगों को मतलब इंटरव्यू में पूछा जा सकता है. कोई भी इंडस्ट्री में जाओगे या कोई भी इंटरव्यू फेस करोगे. What is the ranges of thermistor? So ranges जो होता है ये -100 डिग्री सेल्सियस टू +300 डिग्री सेल्सियस में इसका टेम्परेचर में ये काम कर सकता है. ओके, सो ये क्वेश्चन बहुत इंपॉर्टेंट है. सो आप थर्मिस्टर को -100 डिग्री सेल्सियस टू +300 डिग्री सेल्सियस तक इसको मतलब इंडस्ट्री इसको यूज कर सकते हैं. ओके, अप टू दिस पार्ट इट इज ओके.
Yes, sir.
Now another last question, today's last question, applications. What is the application? देखो ये बेसिकली तो यूज होता है टेम्परेचर मेजरमेंट के लिए. तभी हम लोग डिफरेंट एप्लीकेशन के लिए भी इसको यूज कर सकते हैं, वो भी हम बोलेंगे. नंबर 1 डिजिटल थर्मोमीटर. यू नो दैट थर्मोमीटर. So using this thermometer you have to easily measure the temperature. Thermometer इसको बोलते हैं डिजिटल थर्मोमीटर. इसको हम लोग ऐसे भी बोलते हैं ओनली थर्मोमीटर. These are same thing. नंबर 2 ये कहाँ पे यूज होता है? ऑटोमोटिव एप्लीकेशंस. You know that I am given details. Automotive application. जैसे मान लीजिए आप लोग 4 व्हीलर चलाते हो या कई अभी आज मतलब मॉडर्न एज में अभी बाइक में भी यूज हो रहा है. देखोगे आप 5 सीसी जो बाइक चल रहा है, जैसे मान लीजिए रॉयल एनफील्ड पे हिमालयन या डोमिनर 400 सीसी जो चल रहा है एक्सेट्रा. सो इसमें देखोगे कूलेंट सिस्टम रहता है सर. सो दिस कूलेंट सिस्टम में क्या है, ये एक थर्मिस्टर सेंसर को और ट्रांसड्यूसर को हम लोग यूज करते हैं. पर्टिकुलर टेम्परेचर अगर वो मोबिल जो यूज हो रहा है मतलब इंजन ऑयल जो यूज हो रहा है ना, उसका टेम्परेचर एक रहता है. जब भी वो ऑयल हीट हो जाता है तो वो सेंसर मतलब आपको अलर्ट कर देगा, या वो ऑटोमेटिक भी सेटिंग होता है, ऐसे इसको कूलेंट करना होगा. सो यूजिंग दिस thermistor we have to easily measure the temperature of the engine oil. so ये कार में भी हो सकता है, फोर व्हीलर में भी रहता है, और बाइक में भी अब आजकल मतलब आ गया है. So this is basically uses for the automotive application. So it is basically uses to measure oil and coolant temperature. Okay. Number third, it is uses for household. मतलब आप लोग घर में भी यूज कर सकते हैं, जैसे हम बोल रहे हैं, जैसे आप लोग माइक्रोवेव यूज करते हैं, माइक्रोवेव में जो सेंसर रहता है, ये थर्मिस्टर हम लोग यूज करते हैं. फ्रीज यूज कर रहे हैं ना, फ्रीज में भी ये यूज होता है. जैसे मान लीजिए कोई ओवन यूज कर रहा है, जैसे गैस जैसा होता है ओवन, इसका भी टेम्परेचर हम लोग डिटेक्ट कर सकते हैं थर्मिस्टर. दिस इज द बेसिकली हाउस होल्ड एप्लीकेशन. अनदर वन, रिचार्जेबल बैटरीज. यू नो दैट रिचार्जेबल बैटरी जो यूज होता है, जैसे फोटो कैमरा भी यूज होता है, वॉचमैन में भी यूज होता है, कहीं पे भी डिजिटल वॉच में भी यूज होता है. उसमें टेम्परेचर डिटेक्ट करने के लिए हम लोग ये यूज करते हैं. अनदर वन, इलेक्ट्रॉनिक्स, डिफरेंट इलेक्ट्रॉनिक सर्किट. ओके, डिफरेंट इलेक्ट्रॉनिक सर्किट में भी यूज कर सकते हैं. So these are the different applications. Okay. Another it is also also thermal conductivity, electrical materials के लिए यूज कर सकते हैं. इलेक्ट्रिकल डिफरेंट मटेरियल्स का मतलब टेम्परेचर अगर बढ़ जाएगा घट जाएगा, उसके लिए हम लोग मेजर कर सकते हैं. ओके, सो इज इट क्लियर ऑल ऑफ यू?
Yes, sir.
And it is also uses Wheatstone bridge circuit. It is also uses Wheatstone bridge